Yeah.
We need 10 minutes. All right. Change of base formula.
That's 3.5 minutes per problem.
So the change of base formula tells us, hush children, if I have log base b of a, we can change that into log of a over log of b. Why is this helpful? In our calculators, we only have log base what?
10.
10, right? So if I have a log base b of a, I can't change that base. So we can use the change of base formula to use the calculator. So anytime I have log base b of a, that's the same as saying log of the argument over the log of the base. And they're equivalent. These two values are equivalent to each other. So let's see how we would use something like this. Yeah?
We have done that with like 5, or log 5 20 times.
You could have, but wouldn't that be so pointless?
Yeah.
But yes, it would have worked. Hello, Mr. Colodi. Thank you. All right, let's do a problem. So if I have log base 2 of 17. Now, before today, how would we have done this problem? Before today, we would have said, okay, well, 2 to the x is equal to 17. There would be no way we can do this by hand, so wouldn't we have to take the log of both sides? Yes, but we don't have to do this anymore. We can use the change of base formula. What does the change of base formula tell us? It tells us I could have log of the argument over the log of the base. So I'm not going to pull up my calculator because then it will stop recording, but you guys in your calculator do log 17 divided by log 2. And we get 4.087 exactly. All right, you guys do this one. Yep, this is part of the 4 problems. Log of 3, log base 3 of 3.3. Your whole argument is 3.3. Yes. That's a decimal point. 3.3.
Wait, actually, why did it say that? We don't know. In Bridgewater.
All right, guys, what'd you get? 1.087. Does anybody need to see the setup here? Good. Okay, 2 problems down, 2 more to go. We ready?
I'm ready.
Okay, third one. I want us to write the inverse of y equals 3 raised to the x minus 2 power.
So would it be like x equals 3 to the y minus 2 power?
Good, but we're not done there, right? So here what we want to do, whenever we're asked to find the inverse of something, we switch x and y. So I'm going to have x is equal to 3 raised to the y minus 2 power. But we then, after we switch x and y, what do we then have to do?
Solve for y.
Solve to y. I'm going to tell you to change the exponential to logs, or to log. So remember, when we change to a log, it's log base answer equals exponent. It means I like you. I only use rainbow for the students I like. It took a while, but now I like you guys. Not everybody, Augie. Okay, so let's change this. So we're going to have log base of what? 3. Right? Then our answer is x equals our exponent, which is y minus 2. Now remember, we now were finding the inverse. I need to isolate that y, right? So now I'm going to add 2, but I'm not going to add 2 to the argument. I'm not adding it. I have to add it to the whole log expression. So just so you don't mess up on that, what you're going to do is you're going to write y equals 2 plus log base 3 of x. That way you don't forget and put it in with the argument. Put it in the front of the log. And this is the inverse. That's it. All right, one more and then we're done. So I now want to write the inverse of y equals the ln of x plus 3, that's your argument, and then minus 2 outside of that. So now for this, what we want to do is we are, again, when we want to find the inverse, we switch x and y. So I have x is equal to the ln of y plus 3, and then outside the parentheses, minus 2. And our goal is to solve for y. So my first step, Henry, my first step is to move that 2 over. So I'm going to have now x plus 2 equals the ln of y plus 3. Any guesses on what I'm going to suggest we do now, David?
Convert the ln plus 3 to y plus 3. Oh, wait.
Put an ln on the other side.
You can't just put an ln on the other side. Either you do ln on both sides to keep the equation balanced, or you can't do anything at all. Convert to exponential. You got this. We are going to convert to exponential. So now remember, if it's helpful, ln is log base e. So now when we convert back to exponential, we're going to have base e raised to the what? X plus 2 is equal to y plus 3. Is this my final answer? No, I'm going to now subtract the 3. So e to the x plus 2 minus 3 is equal to y. And that is the inverse. All right, we're done. See how painless that was?
That's the whole lesson.
That was I mean, I had 2 problems for you to try on your own, but it was the same idea. So, we'll stopping.
So,